Okay, so here's where we get into something a little bit new. Now if you notice, we've got something different. We now have a binomial involved in the problem. And so therefore, this is where it becomes extremely critical that we start working with making sure we're trying to clear the denominator or multiply and treat it like a division problem. Here in this case, I see 6 and 3. I like those numbers. I'm going to find my LCD. So when I go ahead and do that, my LCD is going to be 6. Yes, I could do 18. Let's make our lives easier and go smaller. So I'm going to multiply both sides by 6 over 1. And when I do that, these cancel, leaving me with 15 minus b. And over on the other side, I have 3 and 6 both dividing by 3. 3 goes to 1. 6 goes to 2. So now I have equals 2 times 2, which is 4. Now, this is where it looks a little bit trickier. So we have to get rid of this 15. A lot of you are inclined to add 15 because you see this minus sign here. However, remember that minus sign goes with the b. So instead, this is a positive 15. So to get rid of it, we need to subtract 15. So we're going to subtract 15 from both sides. That cancels right here, leaving me with negative b. Remember that negative sign has to stick with the b. And 4 minus 15 gives me negative 11. Now, a lot of you are inclined to stay there. However, remember we need a positive b for an answer. So if you get up to a point where you have a negative variable, that's like having that invisible 1 there. So we're going to divide by negative 1. And by dividing by negative 1, it cancels those, which gives us b. And negative 11 divided by negative 1 is 11. Now the question that has come up already from some of your classmates has been, if I see a negative variable, can I just switch the sign of the variable and switch the sign of the number and just rewrite it? Yes, I would be okay with that. Moving on to the next example. Now it's over on the other side, not a big deal. Here, 10 and 13, because that makes kind of a large common denominator, I'd rather treat this problem like a division problem. Here I have dividing by 13, so I'm going to multiply by 13 on both sides. So here on the right it cancels, that leaves me with y plus 6. Now over on the other side, this gets kind of sticky. We've got 13 times 12 over 10. Now if you recall, 12 times 12 is 144. So we need to add another 12 to that. So plus 10 would be 154. Plus another 2 would be 156. So we have 156 over 10. Now some of you are going, well, do we have to change that? Your best bet? Yes, change it. So 10 goes into 156 15 times, and I know that because 10 times 15 is 150, which leaves 6 left over. So I got 15 and 6/10 equals y plus 6. Now, I go ahead and I got to subtract 6 on both sides to help me out. So then I'm going to come over here, since I'm running out of room, and I'm going to go ahead and say, well, that 6/10 I can leave, but I'm going to simplify it already, which I know is 3/5. So then I take 15 minus 6, which I know is 9, which gives me a solution of 9 and 3/5 equal to y. Let's look at another example here. W plus 3 over 2 equals 8/3. So now I'm going to let you pick your option. Go ahead and pause the video for a minute, and then when you're done, play it again and check to see if you did this one correctly. I'm going to choose to use the LCD method. In this case, our LCD is 6. So when I go ahead and multiply both sides by 6 over 1, I'm going to result in having the 3 cancel to be 1, 6 becomes 2 because it's divisible by 3, 8 times 2 is 16. On the other side, 2 becomes 1, 6 divided by 2 is 3. So now I've got 3 times w plus 3. So I have some distributive property to use. So I'm going to go ahead and bomb out that 3, giving me 3w plus 9 equals 16. So now with this problem, I need to go ahead and subtract 9 from both sides, which results in me having these cancel, giving me 3w equals 7. Then I divide by 3 on both sides, canceling the 3's, giving me w equals 7/3, which 3 goes into 7 twice with 1 left over. So w equals 2 1/3.